Alright, so College Board recently released brand new questions for the SAT, about 120 of them. So I went through all of them, I solved all of them, and I picked, I believe, the 5 hardest ones that we're going to go over today. Here we are on our first question, and this one looks very annoying because you'd either have to do like the Pythagorean theorem or distance formula to solve this question, but thankfully, we're given these points, so all we have to do is just plug and chug into Desmos, alright? So let's go do that. Alright, so here we are in Desmos. What I'm going to do is I'm going to label this point right here. It's going to be A. Okay, so the coordinates of A are -4, comma, -1. Okay, now we're going to go to B. Let's call this point B. B is going to be 4, comma, 5. Alright, so now what we can do is we can solve for the distance of those two by just doing distance A, comma, B, and that gives us 10. Alright, so now what we're going to do, we're going to solve for the distance between these two. Let's call this point C. So C is equal to 7, comma 1. Okay. Now what we can do is we can multiply the distance of AD times this, which would be the distance of BC, which would give us our answer of 50. Alright, so this is an absolute beast of a problem. Probably one of the hardest geometry questions we've ever gotten from College Board. Just take a look at it. In the figure, EG and AD intersect at point F, okay? And then line L is parallel to line J, and then we have all this extra information here, right? So, which of the following must be true? Let's take a look at this model. Alright, so we have a lot of stuff going on here. First off, we have parallel lines here. Alright. So we also have these two angles are the same. They're both x. And what that tells me that EFG also has to be parallel to these two lines. The reason for that is because if you have alternate interior angles, that means that the lines have to be parallel, and we have alternate interior angles right here. Okay. So our next step, let's look at this. We have EF is equal to 0.5 CD. Okay, so EF is equal to 0.5 CD. This is CD, by the way. All right. So I'm gonna assign like random numbers here. Okay. So let's say EF is 1. That means that CD has to be 2, since EF is 0.5 CD. Okay. Now that we know that, we know the scale factor between this triangle and this whole big triangle is 2. Okay, this whole scale factor is 2. Alright, so what we can do with that now is we can from there we can tell, that means that these two sides, they have to be equal. Because let's say this one is, I don't know, let's say this one's B. Okay. That would give us, for this whole side, 2B. Alright. And we know that if this triangle is, this side is B, that means that the other side has to be 2B because the scale factor is 2 in this case. Alright, so that's how we know that those sides are equal. Alright, so now that we know those sides are equal, what we're going to do is we're going to look at the next triangle, okay? So this next triangle is the same case. This triangle here, this one, is going to be similar to this triangle, this whole big one, right here. Alright, so, and same thing, it has to have a scale factor too, because look at this. The B value here, there's a B value here. They add up to 2B, which means that the scale factor has to be 2, because this is B, this whole side right here is 2B, okay? So, let's assign a value to these sides, okay? So let's say this one's 2, and this is 4. Actually, I shouldn't repeat numbers. Let's say this is 3, 30. Let's say this is 60. You know, it's not to scale very well, but that's all right. Okay, so let's take a look now. Okay, so our first rule, our first choice, AB is equal to 2.25 EF. All right, so let's look at AB. AB is 60, and then we have EF, which is 1. So is 60 equal to 2.25 of EF? Definitely not. Definitely not. All right, so this one would be absolutely wrong. All right, let's look at the next one. FG is equal to 0.5 AB. Okay, so FG, which is 30, is equal to 0.5 AB. So 30 is equal to 0.5 60, which is absolutely true. 30 is equal to 30. All right, so we're good on choice 2. All right, now for our last choice 3, EF over FG. All right, so 1 over 30 in this case is equal to AF. Let me erase some of this stuff, and I will keep it. AF over FD. All right, so this side over this side, which is just equal to B over B, which is 1. So 1 over 30 is equal to 1. That's absolutely wrong. 3 is wrong. 2 is our only answer. Our choice is B. Alright, so if you thought we were done with triangles, we're definitely not. Okay, so we have this very annoying one. Alright, so in this triangle ABC, AB is equal to BC. Okay, AB is equal to BC. Points D and E lie on line segments AB and BC, respectively, such that line segments DE and AC are parallel. Okay, so these two are parallel, nice and parallel. Okay, awesome. All right. We also know that O is the midpoint of line segment DE, so O is the midpoint. That means these two are equal. And the measure of OAC is 30. OAC, this is 30. Okay, we already know that. Point F lies on line segment AC, and line segment BF passes through point O. With AB, so AB is 81. Okay, and AO is equal to BO. AO is equal to BO. What is the line length of line segment BE? Okay, this is a very tricky problem. Okay, so the first thing we have to do is we have to recognize the angles. All right, so if O is the midpoint of DE, that means that this line, this angle, has to be equal to 90. Okay, it just has to. So if this is equal to 90, what we know is that this angle right here now has to be 60. Okay, and if that angle is 60, this whole angle would have to add up to 180, right? So the rest of this angle would be 120, right? All right, so now this is the big part. We know that this is 120, and we also know that this is an isosceles triangle. AOB is an isosceles triangle because AB and AO are the same length, okay? So if this is isosceles 120, this has to be 30. This has to be 30. Okay, so we have 30, 30. Awesome. Alright, so now that we know this is 30, this whole angle would have to be equal to 60 now. Okay, 60. Alright, so we know that now. Alright, let's get rid of all this junk now. Alright, so we still know. Alright, so now that we have our 30, 60, 90 triangle, all you have to know is that since for this side, this is equal to that because it's isosceles triangle, so this is also 60, and then this is also 30, which means that they are similar triangles because of AA similarity. Okay, so let's see. All right, so our next step here, we would have to recognize that this is a 30, 60, 90 triangle. Okay, so the 30, 60, 90 triangle. Let's call this B. Let's call this side B. All right. So if that side is B, that means that this side has to be B square root 3 according to our special triangle rules, and this one has to be 2B, right? Now if we know this is 2B, what we can also determine is that this side is 2B, right? Because AO and BO are the same, right? So that's going to come in handy. So if we know that this is B, and this is 2B, added up, they're 3B, right? So this whole thing, sorry, it's gonna get messy, is 3B. 3b. What we can now know is that this smaller triangle right here, which happens to be similar to this bigger triangle right here, they have a scale factor of 2/3. All right, so there's a scale factor of 2/3. So now that we know that scale factor of 2/3, what we have to do is we have to multiply 81 by 2/3 because the scale factor is 2/3. So 2/3. So we get our this side, which is 54, and this side must be equal to BE because they are the same triangle. Okay, so this is also 54. So that's our answer, 54.